the session is connectivity patterns in a cloud-native application world. And why connectivity is important, we will go over that. So what are we going to be doing today in the following 30 minutes? We will be talking about the challenges of multi-cloud, as you already answered. We do know that there's something going on there, and we need to be able to see how we handle it. Then the second thing we're going to be covering is obviously the patterns that we have seen, and then at the end we're going to be doing a recap, summary, and if time it's good with us, then we will be looking at the demo. My information is here, just quick introduction. I'm working with Red Hat as a developer advocate. I specialize in APIs, messaging, and application connectivity in general. I think it's different angles of the same thing. We really want to connect applications. I'm also an open source contributor, so the microbes maintainer from the for Docker extension for APIs. I also are a Sync API ambassador, so I also bet too much into standards and contracts and EDA. So if you want to follow me, use the Twitter handler. You can follow the conversation offline, or we can just meet and bump in the hallways. Great to have a conversation with you. So let's get started. In the beginning of the times, like 5 years ago, long time ago, we used to live in an Eden where everything was good and everyone was happy. And that was actually the monolith, or after that, the mainframe, the single cluster, the single cloud, my own data center. And we were happy and was easy to handle because everything was in the same place. We all knew each other. We all have control of the resources. We were able to share a lot because, we were family. We all knew who was doing which API, where was it deploying, who was ownership of that. So it was paradise. It was a great experience, but it was limited, and we actually get into some troubles because suddenly we realized that that idea of I'm going to deploy on just one single cloud provider, or I'm just going to keep my own data center. We realized that we are having the requirements from business, from regulations, from legislation that you need to be able to, spread across the world with your data centers, but not my personal data, or not this kind of data, or you can do it, but it will cost you too much. So moving terabytes of data from one region to another, yes, more money for the cloud providers. So there are different reasons what put us in this spot where we suddenly realized that, single cloud, something we really were looking for, but it's not what we actually ended with. So, a couple of reasons why you can find. Best of breed. I want to get the APIs from Google because their AI/ML machines are awesome. But storage it's cheaper with S3. So why not having both of them? So that gets into this nasty space where suddenly you realize that if you have seen about this movie, remember how it starts with this cuddle thing, the gizmo one, and then suddenly it transforms into this. So this is how I feel as a developer when I suddenly realize that, okay, my application is running on local host, but then suddenly it's like, okay, and then how do I put this in AWS and at the same time connect to the database running on my data center, and then everything gets complicated. So I feel like I'm just, dealing with this guy. It's not just cloud if you're, backend developers, UI developers, but what about the edge, right? So today in every KFC, in every subway, you will see a computer that is handling data and is taking actions and is responding to events, and you need to be able to code and develop applications for those environments. So why is it so ugly? Because there's a reality. There's multiple versions of clusters, multiple versions of VMs, of operating systems, different operating environments where we need to deploy our applications. And from the connectivity perspective, there's also some challenges that are perhaps more from the infrastructure side, like, overlapping CIDRs, conflicts on IPs, VPNs, firewalls. Who of you really love to submit forms to open ports in the firewall? Yeah, no one, right? It's one of the things that you never want to do. Having to justify why you need to open a port, why you need to add a NAT key to the wide list. So yeah, there's different challenges, and there's because nobody really is starting with greenfield applications. It's very, very difficult. Someone says like, oh yeah, I'm a totally brand new organization, and I'm going to start everything from scratch using Lambda. Now, most of the times, you already have systems running on Visual Basic 6, and you need to be able to connect with Excel data kits, and so on, so on. As I was saying there, with these challenges, when suddenly we need to, at the end, being able to do this kind of connectivity when we have simple scenarios like, okay, I need to connect from my private cloud, my data center, where my, more protected and sensitive data is stored, but being able to share information with the cloud. There's a classic private-public cloud connectivity. And when we are talking about edge, we are talking about the challenge of being able to connect one location from Subway to the next location of Subway, being able to, exchange, if there's people from Walmart, you want to check the inventory in each one of the stores, so you can suggest people where you can find the item if it's not available in the store, and so on. So again, other connectivity challenge. So those are, some common scenarios where we can find these kind of challenges. But what we really want to achieve, what we really want to get as an ideal version of the world, is that we can see everything as a mesh, as a connectivity tissue, where it doesn't matter where something generates. If we are talking about EDA, if an event is triggered somewhere in my architecture, I should be able to capture and consume or listen to that event in any single place where the application is connected, and without thinking about how it was located, where it was located, or what it was the detail of the connectivity that I have at the application level across those clouds. So it's basically what Kubernetes did to us for compute power and resources, where we don't think about VMs anymore. We just think about nodes and containers, pods, volumes, and know, oh, is this a Hitachi storage server, or I'm connecting to an Intel VM? I don't know. So Kubernetes did that for compute. We want to do the exact same thing for connectivity, where we just have building blocks where we are connecting and listening to endpoints or destinations, and then being able to have this connectivity automatically route through the infrastructure without us as developers thinking about how do I connect and consume a Kafka topic? How do I connect and consume to the API gateway that is protecting my application, and so on. So in this example that you can see in this diagram, I have an Oracle database, and then I have a very old application that is inserting data there. Obviously, the people that was developing that application, they have retired, so it's no one is going to be touching that code anymore, but we still need to get that information. So we can implement patterns like change data capture, and being able to then push an event into the mesh, and then consume that event and trigger a Lambda function or a Knative function in Google Cloud, but at the same time have a fan-out pattern to be able to connect and get the information into the data lake for, further processing and so on. So this idea, it's the connectivity mesh. It's one of the concepts that we have been working. You can certainly have heard about that as the event mesh, or the connectivity mesh, or the connectivity tissue that allows us to have this service network, its interconnection to their different domains that can be different location, right? The data centers on premise, one cloud provider, no cloud provider, two different clusters in the same data center, but separated independently. So let's go on the patterns. The first one, you already know it. It's APIs. It's the most common pattern used to connect applications. But as we have seen across the whole day, there's trade-offs, right? Yeah, it works pretty well for things like north-south traffic, east-west traffic, where you have components like API gateways that allows us to have a better control, some traffic management, some policies that allows us to be able to have a certain control of the traffic. The downside or the trade-offs of this kind of patterns deals with how do I secure that, right? So most of the times I will need at least an API key, but how do I get the API key? How do I enroll my application? Do I need to know exactly where to get the API key? Where is the API gateway? What happens if tomorrow they change the API gateway or the contract and things like that? So you have been using this. It's a very easy way to get started, but also force you to use protocols like HTTP as if you're using REST APIs or if you're using GraphQL. And the protocol itself has some limitations, right? So that's one of the trade-offs for using this. The gateway is the classic pattern to establish that. You have a request, you get into, for example, a Kubernetes cluster or a VM where you have the gateway that is actually a policy enforcement point where your call is being accepted, validated, that you have access to your application, and they've been able to forward that. There's a pattern 0 that is just a bare naked HTTP endpoint, but I will assume that if you have ever spoke with your chief security officer, that's going to be a big no-no for you. So, second pattern, in sake of time, store and forward. And this is if you raised your hand when we were asking about EDA, it is basically a way to decouple in time the communication between your services. So REST APIs or HTTP or APIs in general require you to have both services running at the same time, right? The client and the server. If the server is not there, yeah, you cannot do anything. So you break your application. In this case of store forward, you delegate the concept of you delegate to a concept called the broker the ownership of your data and your communication. So you have a middle piece that then it's in charge of connecting asynchronous your producers and your consumers. So if I want to send data from one place to another, and I know that connectivity is not going to be perfect, it might fail, but I need to be sure that the message is being delivered at the end of the time, I will use the concept of broker, where I have a seamless communication, I delegate that to the broker. The broker then waits for the consumer or the receiver to be available, and then being able to deliver that. But I don't need to have the producer being available at the same time. There are patterns like Kafka, where you are even able to replay those events, send that information multiple times to the consumer if that's the way that you really want to handle that. This is how it looks from a diagram perspective, where you have your application perhaps running on the edge, connecting to the event bus, implemented in different protocols. We will see those there. And then there's a way to replicate or copy that information into another place, could be a public cloud or your data center, and then that information is then put back into the bus, so your application is able to consume that. If you see the connection direction, you most of the times will replicate into a single place, or mirroring if you already have connectivity here. And you can do that transformation and flow direction bidirectional if you want. Now, as I was saying, there are different protocols to implement this, from AMQP, Kafka, Knative events, and cloud events allows you to have standardization, and this abstraction blocks that allows you to think about only a broker and only a cloud event, and not need to go on the details on, I'm using NATS, or I'm using Kafka, or I'm using an in-memory queue for handling my communication. So Knative is an interesting building block for the mesh. Now, third pattern, cloud services. So this, again, is one of the simple patterns to implement and to use. It's basically I'm delegating the ownership of and storage of my information to a provider. In this case, if we review the diagram, we will see something like this. I have my application that must have a connectivity with a public service, and then being able to use another application to then retrieve information stored in that service. So in this case, most of the times you won't have a direct connection between your application. You will be using this as the middleman or the broker to be able to handle that information. And that information can be in different ways, right? The most common services you can find is, S3. If you want to share information between the S3, you will certainly write and then read from another application. If we are using Salesforce, as our friends are here in the expo, Salesforce is a cloud service where you will be sending information to Salesforce, and then another application will be consuming that information from Salesforce. Could be a UI, a dashboard, or it could be just, an integration. Slack, it's another example of a cloud service where you will be using this kind of patterns. So there's a lot of benefits and the trade-offs. Yeah, it's easy to use. That is stored in the service. Most of the times it's in only, so it's really there are few services that allow you to retrieve the information automatically or in a streaming fashion. It's interesting because they provide SDKs, boilerplates, or even already connectors ready for your applications to be able to use that. Some of the trade-offs, as I was mentioning, you delegate everything to the cloud service. Remember, and when we had some fails in AWS last year, if the service is down, then your whole system is down. You expect them to pay for the complexity and such, but there's a risk that they will fail or they will stop serving you. You will need to reconnect things and so on. The last pattern that I want to talk about it's the service network by itself. And the service network is this new concept that has been discussed in the past, I think with the name of virtual application network, or the mesh, as I was mentioning, where what we are doing is we are pushing the complexity of the connectivity to the infrastructure, as similar to what we did with Service Mesh and Kubernetes, to just forget about where our service is running and have the concept of a virtual service being created in our network, so we are able to consume services that might not be running on the same location or in the same site as the services that are consuming or trying to connect. And the idea of this abstraction, as I was mentioning, it's for you as a developer to think just of an endpoint that I'm going to be consuming and not details on where that endpoint is running or what kind of technology they are using for running that service. How it looks on the diagram side? Well, the idea is that you will have a common service network being created with all your different endpoints available, but the implementation of the service will be running on different clusters, right? Thinking about Kubernetes, but this can apply to other VMs or bare metal. You have a connection, could be TCP or could be HTTP, and then being able to route through the network and being able to consume any of those services. The service network needs to allow us to not only have discoverability of services and being able to locate them, but also being able to handle a simple traffic management to be able to define if the service is not available. Well, obviously, drop the connection, send an error, but if there's a service available that can fulfill the request, but is running on a different site, you should be able to reroute those automatically without having the consumer be aware of how that's working. Kind of example of an implementation that we have been working with some customers looks like this, where we have an application that is exposing a service, and we have another application that wants to consume the service. We usually do, implement any of the other patterns, but what we want to do is that we want to be able to this application to consume, and connect with this application. But those are, living in a different site. So how do we do this if we don't have a direct communication between them, right? Because it is insecure, or because it's running on, the edge, right? We're not going to be exposed in the edge. So what we create is this route using things like TCP over MQP with TLS to have zero trust network, mutual TLS tunnels that connect different sites and that create this virtual network. The important part with virtual is that, as I was saying, what we get, it's not a copy of the service running locally here, but just a pointer. If you have seen the Star Wars movie, when they have the Jedi Council, you see, Jedi sitting in the council, but they're not really there. It's just, a hologram. So it's similar to that, right? Where you have a service that is being exposed here through the router, but it's actually just a stub that connects this. If you have been long enough in the technology side, if you remember remote AGVs, it's something similar, but without having to involve code in this. So a recap of the patterns, because I think we are almost running out of time. We have talked about APIs. We have talked about store and forward. We talk about cloud services and service network. And if everything goes correctly and the demo gods are with us, I will be able to show you how the service network should look like. Okay, I have here a Kubernetes cluster running on OpenShift. And I have just, a couple of services. I'm using Scopper as the way to implement my service network. And I have a couple of routers. So what I'm going to do is that I want to expose a service that is running on my laptop. So I have here a simple REST service using, something like Apache Camel. So I do Camel run. With YAML, and this is going to be running on my laptop. But what I want to do is I want to use my cluster that is running here, expose my application that is running on my laptop, and being able to access that directly from my Kubernetes cluster. So my application is running here. Let's see if I can say hello to my application. Yeah, hello, Camel. And then my application is running locally, as you can see, port 8080. So let's create a network. Currently, we are using, as I was saying, Scopper that has a route. So let's see, we can see the console where I only have one site created. So let's create a gateway. I have a definition here of a simple configuration, so I will do gateway. Neat. I'm just going to implement a router that is going to be able to run via Docker, and will connect to my sites. And yeah, it didn't work. Let's try again. Yeah, Scopper just has a way to see the network and the services that are available. It is a way to check configurations and connections across different sites and see the flow and the processes that are available and that are running there. So yeah, unfortunately, something's failing. And yeah, demo didn't work. Just getting back to the service network and the concept of the design of the service network is that there are different patterns to be able to connect your applications. All of them have different trade-offs. Some are easy to use, some are less expensive than others. So you will need to weigh the trade-offs of how you're going to be implementing your connectivity and your applications. Some of them require more resources from the infrastructure perspective, but the idea is that most of them will not require you from your application perspective to implement too much code. There has been development recently on different components to be able to abstract as much as possible the interactions that you have with those services. Knative is a great example on how to abstract brokers, channels, subscriptions, and so on. And the idea of the service network allows us to abstract even the concept of API gateways. Because one of the challenges that we have with application connectivity, as we were mentioning, is that we are creating artificial barriers between our different components, between two different sites, even though it's going to be solving a single application use case. Now, as I was saying, we are working with APIs. We're working event-driven architecture. So if you have already used Microx, I encourage you to try it, check it. If you're using event-driven architecture, we suggest you to take a look at the Sync API. The community and initiative on the Sync API is doing great things to be able to provide you with tools similar to what we have from the REST API world, but to be able to interact with brokers like IBM NQ or Kafka or NATS or any other bindings, so you are able to simplify the way to interact with your applications. I think that's all for today. I know it was a lot of content. I really want you to, take the different patterns, take a look closer. We have some additional content on our developer site at redhat.com, developers.redhat.com, and thank you very much for your time. I really appreciate it.